Friends, welcome to my YouTube channel PCM Academy. Myself Prasenjit Mallik, M.sc in Physics. And in this class, we will discuss about special kinds of differential equation, that is Cauchy Euler's differential equation. We are actually in a series of mathematical physics for IIT JAM and JEST also. The videos will be also helpful for JEST. But for NET and GATE, most of the topics I have not discussed till now. But after finishing the course of JAM, I will discuss about the course for NET and GATE also. Okay. So if you are new in this channel, then please subscribe my channel and hit the bell icon so that you will get the notification of further more updates. Okay. So we are actually in a lecture series of differential equation, and today is the last class of differential equation. Then we will start the matrices. Okay. So here in this class we will discuss about Cauchy Euler's method, and actually till now we have discussed about the differential equation which have constant coefficients. Okay, so till now we have the differential equation something like this, that is d2y dx2 plus p into dy by dx plus qy is equal to r. So this kind of differential equation we have discussed. We have discussed separately complementary function and the particular integral also. But now we will discuss a special kind of differential equation where the coefficients are not constant but they are in a particular form, that is the order of the differential equation and the degree of x or the power of x of the coefficients is same, something like this. X square d2y dx2 plus x dy dx plus y is equal to r, this kind of equation. Let me take first for right hand side 0. Okay, so if we have this kinds of differential equation, that is x square d2y dx2 plus x dy by dx plus y is equal to 0, then we can solve this equation by using Cauchy Euler's method. Okay, and this differential equation we have studied earlier. Okay, so you can go to the playlist and you can see all those videos for differential equation, for first order differential equation, second order differential equation, for complementary function, particular integral, all are discussed there. Okay, so now this equation, this particular type of equation where the coefficient, the power of the coefficient is same as the order of the differentiation. Here also power is 2 and the order is 2, here power is 1 and the order is 1, you can see. So these kinds of equation we can solve by substituting x is equal to e to the power z. Okay, and if we take this x is equal to e to the power z, then we can substitute also this x ddx as ddz, and this will denoted by capital D, symbolic form. Similarly, we can substitute this x square dy dx d2y dx2 as d into d minus 1. Okay, and if you have x cube dqy dx cube, then we have d into d minus 1 into d minus 2. So we have to substitute this. This can be proved, but you don't need to do this. You can directly substitute. If x ddx, there is d, x square d2y dx2, dd minus 1, x cube d2y dx3, dd minus 1, d minus 2. So we can substitute in this equation. You can see is x square d2y dx2 means dd minus 1. So it will be dd minus 1 plus x into dy by dx, that means just dy. So y plus dy plus y is equal to 0. Okay, now if you write the auxiliary equation, then you will get y is common, then you will get d square minus d plus y equal to 0. So this is your symbolic form, this is the auxiliary equation, and you know how to solve it from the concept of complementary function. So you can cancel this d and d, so it will be d square plus 1 is equal to 0. So d will be plus minus I. So two roots are there, one is plus I and another minus I, roots are complex conjugate. So we have the solution of this kinds of differential equation, you know, that is the a sin e to the power alpha x, a sin bx plus cos a sin bx, a sin beta x plus b cos beta x. So this kinds of solution are there for alpha is equal to I beta, for the root alpha is equal to I beta, you know, and here alpha is equal to 0. Okay, for alpha is equal to I beta, we have the solution y is equal to e to the power alpha x into a cos beta x plus b sin beta x. These kinds of solution we have. Okay, but here you know that beta is equal to 1 and alpha is equal to 0. So what you will have? We will have this y is equal to just a cos x plus b sin x. But here the variable is z actually. When you put e to the power z, then this d is written in place of d dz. So your solution will be in terms of z. So it will be a cos z plus b sin z. Okay. Now you have to substitute the z. So you can see from here that z is equal to ln x. So z is equal to your ln x. So your final solution will be right over here. Your final solution will be a cos z means ln x plus b sin ln x. Okay. So this will be your final solution. This is the complementary function actually, and the right hand part is 0, so the particular integral will also be 0. So you will have this kind of solution. Now let me solve one more example by using this method. When there is right hand side, so you have to find out the particular integral as well as the complementary function. Okay. So let me solve this kinds of equation one also, so that you can understand how you can apply this Cauchy Euler's method. Okay. So let me solve one more equation. You have to just put this x is equal to e to the power z and x d dx as d minus 1 d and x square d2 dy dx2 as d minus 1. Okay. So now let me tell you one more problem. That is x square d2y dx2, x square d2y dx2 minus 2x dy dx minus 2x dy dx minus 4y is equal to x to the power 4. So you have right hand side. So what we have to put? We have to put as x is equal to e to the power z, x d dx as d, here d means d dz actually. Okay. And x square d2 dx2, we have to put this as d minus 1. Okay. So this will be d minus 1 minus 2 into x d dx means d minus 4 into y equal to this x to the power 4 means what is x to the power 4? It is e to the power 4z. Okay. So this will be e to the power 4z. X means e to the power z, so x to the power 4 means e to the power 4z. So what will be your auxiliary equation? To find out the complementary function, you have to solve this equation first. So it will be your d square minus d minus 2d minus 4 equal to 0. So it is nothing but d square minus 3d minus 4 equal to 0. So it is nothing but d square minus 4d plus d minus 4 equal to 0. So this is d into d minus 4 plus 1 into d minus 4 equal to 0. So it is just d minus 4 into d plus 1 equal to 0. So your d will be 4 and minus 1. Okay. And you know, for this solution, the solution will be, for the complementary function will be here c1 e to the power m1x, that means 4z here. Okay. And c2 e to the power m2x, that means here c2 into e to the power minus z. Okay. So this is your complementary function, and if you substitute this 4z, what is this 4z actually? Z is equal to ln x. You can see this z is equal to ln x, so it will be just c1 e to the power ln x to the power 4. It will be ln x to the power 4 because the coefficient of ln will be in the power. So it will be ln x to the power 4 plus c2 into e to the power ln x to the power minus 1. Okay. So it will be c e to the power ln x to the power 4 means simple x to the power 4. So it will be c1 x to the power 4 and c2 x to the power minus 1, that means c2 by x. So this is your complementary function. Now you have to find out the particular integral also. So what will be your particular integral? You know, particular integral is nothing but 1 upon f of d into the function that is here e to the power 4z. Now what is your f of d? F of d is this, just d square minus 3d minus 4. So it will be just 1 upon d square minus 3d minus 4 into e to the power 4z. Now if you put this d as 4, then you get here 0, that is here you can see that is 16. Okay. and here is 12 minus 4, that is 16. So 60 minus 16 is 0. So you have to take differentiation. So it will be just z e to the power 4z divided by, you will have 2d minus 3. Now if you put d as 4, then it will be 4 into 8 minus 3, that will be 5. So it will be z e to the power 4z divided by 5. Okay. So what is z? Now again you have to put that z is equal to ln x. Okay. So we have z is equal to z as ln x, okay, into e to the power 4z. So e to the power 4z means again x to the power 4 divided by 5. So that will be x to the power 4 ln x by 5. So this is your particular integral. So your complete solution will be CF plus PL. CF plus PL. So CF is this C1 x to the power 4 plus C2 by x and plus your particular integral will be 1 upon 5 x to the power 4 ln x. So this is your final answer. Okay. So this is your final answer, I think. Let me check. Yes, this is your final answer. Okay. So this is how you have to solve these kinds of problems by using Cauchy Euler method, and you have to check the form in this form. Okay. So that is power of this coefficient is same as the order of the differentiation. In that case only you can solve the differential equation which have variable coefficients also. Otherwise we have only learned about the solution of the differential equation of constant coefficients.